I'm excited to be here talking about something I'm passionate about, and I think the rest of us are, is offshore sailing and trying to keep it all together from beginning to end. My name is Eric Steinberg. I've been doing this, I started Farallon in 1989, and with the goal of high quality craftsmanship and high quality materials. And because I'm a sailor and I like to go sailing and not be working on my stuff when I'm out in the middle of the ocean. So I'd like to introduce another craftsman, Yev Osipov. And Yev is the new owner of Farallon Electronics and has been doing a great job. And he will carry on the tradition into the next generation. So here you go.
Thank you. Thank you, Eric. Thank you for having us, Corey. Thank you for organizing wherever you are. I've actually been stopping around Berkeley Marina for about 20 years. My first boat was a Santana 22, a project boat. I've since learned they're all project boats, but I launched it over at JDock, and I've been sailing out of Berkeley on various boats ever since. Eric doesn't need much of an introduction, but my career is in architecture and home building, custom, ground-up residential. Got pivoted into boat building and marine electronics about 10 years ago, and I've been working with Eric for about 5 years. I think we started working on a custom build over at BMC, an orange pedal boat project that some of you may have seen over there, and then that rolled into another project, eventually Glass Slipper. Eric mentored me through that, and we've worked on a bunch of projects since then.
Yeah, you want to do that?
I don't know how we're going to split off the mic duties.
Shout.
Yeah, so today we're going to talk about marine electronics and power, and I don't know how long this will go, but we'll leave plenty of questions, time for questions, and we can chat with our demo bench later on. Today we're going to be talking about succeeding with marine electronics offshore as a general topic, and we'll go over the common problems, common solutions, an offshore power plan, how to manage your power, supply and demand, and also we'll go over communications. And I guess we can get right into it. 80% of the failures you see are installation related. So when we get involved in a piece of equipment that is not working, after we check that it's properly configured, confirm that it's not working, we don't start swapping stuff out right away. We get into the installation of it, and specifically connectors. We go through wiring, we go through how it's hooked up, and connectors, whether it's coax or power connectors or data connectors of other sorts, they're meant to last a long time and outlive us if they're maintained, kept dry, kept clean. And I like to say, keep the water out of the wiring out of the water. They're different things, because when I say keep the wiring out of the water, I mean keep your coax connections out of the bilge. This is, I'm not sure what boat this is on, but this is an example of a connector that should be, especially this one higher up, and wrapped and kept dry. It's critical for communication.
Yeah, so I just want to, the 80% number was, I had heard that on a debrief from a Vendée Globe year, that 80% of their failures were installation or connector related. And I thought about it, and it's like, yeah, that's a real number. That's, we hardly ever are trading out equipment. It might be more like 90%. And so, like Yev's talking about with this, that if, maybe there's a situation where you have to have a connection in an inhospitable location. Coax connectors are not inherently waterproof, but you can wrap them with a special tape. Not so special, you can get it at Home Depot. It's Scotch 2242. Take note, that's a good one. It's a self-amalgamating electrical tape, similar to what Scott was talking about with the rigging tape, but this is more specifically for electrical. It conforms to shapes better. Anyhow, so that's, if we could do nothing else here, that's what we would do in this situation.
Yeah, so keeping water is the enemy. I think we all know this, and keeping water out is critical. Even water that gets down low, even if it gets past the devices, like I think this is below below floorboards in a boat. We have exposed connectors, we have exposed power conductors. You see plus minus. If water gets in there and it's gonna splash up and down, it's gonna slosh around. Things start shorting, things start tripping, fuses start popping, bad things happen. So if there are connections in water vulnerable spots, like around the mast or at the bottom of the boat, they should be enclosed in the watertight junction box, or they should be at the least wrapped with self-amalgamating tape. Yeah, that's definitely a good start. We want to talk about inspecting everything. So before going offshore, by inspecting everything, we mean everything. Nose to tail, head to hoof, bow to stern, ear to ear. I can go off on that, but starting with bow lights, take them apart. Send someone up the rig or go up the rig yourself and check what's going on up top. But by familiarizing yourself with your boat, turning everything on and off, figuring out what is not working, that's a start. And by taking things apart, you will get to know what will soon not be working, so you can address it and have plenty of time to fix it.
A classic example is a bow running light that's working, but you go to service it and it falls apart in your hand. Well, it was time. So when we talk about inspecting, we really want you, Scott, the same thing that Scott was talking about. Let's take things apart, know how they work, put them back together if they're suitable, and if they're not, let's replace them now. Look at the wire. Is the wire nice and shiny? Does it have a green tinge to it? Is it black? The latter two are cause for concern. And yeah, so inspection is a big thing.
There's a boat that I was recently working on. We did a big refit before the boat went down to the Baja Peninsula in the Baja Haha. And there were parts of the boat that we did not directly work on. They're factory wiring of, I think, a diesel heating system. And a colleague of ours was on the boat, and he was inspecting wiring, or he ran a wire. And there was a splice at the back of the boat up in a factory loom. And mind you, the diesel heater was working, but he grazed it or he just bumped it, and the thing just dissolved and crumbled, kind of think like lemon tart. It just fell apart. And it was working up to that point, then it crumbled, and then it wasn't. So by inspecting, you find these little gremlins, and you realize that you need to fix before you go offshore. Also, we got to talk about splices. When you inspect, if the colors of wire change throughout the boat, if you know that your feeder wires from the nav desk to your bow lights start as red and black, and when you're up at the bow, they are, I don't know, yellow and blue or some weird concoction, you know that somewhere in between there's a splice, and it's a good idea to find it, because you should know where it is, and you don't know how long it's been there.
Yeah,
so,
and it can be more subtle than that too. It can be just like the texture of the jacket on the cable change, and indicating that it's two different pieces of cable that have been joined someplace, and you don't know where that joint is. Might be, in behind a cabinet. You got to stick your hand behind the furniture to find it. But find it. Let's figure out. I mean, and that piece of wire is easy to replace now. It is a pain in the ass at 2 in the morning. And in fact, you might just live without that feature, whatever that piece of wire is driving, until you get to the other end.
Right. And while you're inspecting, you'll find zip ties, lots and lots of zip ties. If you've watched Eric's talks before, he's touched on the importance of snipping them flush, so they're not meat hooks, and no zip ties on top of zip ties on top of looms that already have zip ties. Wire traceability is important now, later, middle of the ocean, after the race. So yeah, please snip zip ties so things don't get caught, including skin. As you do inspect, and as you get to know your boat, you're going to learn what wires are, and if they're not already labeled, during inspection would be a good time to do that. Labels are instrumental, if it's not obvious, in diagnosing, troubleshooting, figuring out causes a problem. Going to talk about workmanship.
All right, so this was my, I had an epiphany thinking about how do you make it relatable to make things neat and tidy. In your kitchen, you don't throw dishes in whatever cabinet you want. They've got a place. Same thing with what we're doing. So,
Yeah. No, that's a fair example. Keeping things tidy and orderly is it's pleasant. This is throwing dishes in your cupboard, the electronics equivalent.
Chaos,
yeah,
right?
This is chaos. So notice, things are unlabeled, coils of water. I suspect that some of these wires don't have terminations, so I don't really see a reason why they were not trimmed tonight. Yeah, it could be. I mean, just cut them. They're already going into a splice box. But yeah, good luck troubleshooting on this boat. Another example of lazy workmanship, this is probably under a bunk. I think Scott talked about chafe as being a really big deal with wires. It's also a big deal because you're there for thousands of miles.
Yeah, I like this. This is, 400 pounds of lead that's glued in, right? So this is weight correctors, probably in a J105 or something. And we've got all this sort of critical wire here. One of those breaks loose, and those get pretty unhappy quickly.
Yeah, also just imagine the weight of all this wire just kind of swaying and pulling on zip-tied coils of wire. Eventually things do saw through. This is a project that Eric and I worked on, I think, maybe 3 years ago. It's a boat out over in Sausalito, and we got in the boat on a Monday, and we were going to be out by the end of the week with a baby, half refit. It already has half of an NMEA 2000 modern system. We were going to add some components and get the boat like a new chart plotter and some new sensors. And we found this behind the nav desk panel. The owner of the boat, our customer, he was an organized fellow. He was appalled.
He was appalled.
Yeah, he was not thrilled, and it was a discovery project just to figure out where to bring where power was coming from to the NMEA network.
So just to drill down just a little bit. So there's the general chaos that it's going to be hard. It's harder to quickly look at this and sort of figure out where the flow of wires are, because some wires are doubling back on each other and all that. We've got a fuse just hanging loose here behind the panel, which is a total bugaboo. That fuse probably goes to a circuit breaker. So why do we have that fuse? First of all, do you even know that fuse is there, and do you have a spare fuse specifically for whatever that's powering? We would endeavor to get rid of that. There are rare cases where you need to individually fuse things, but we would have it on a fuse block instead of these free-hanging fuses if we can help it. So.
Yeah, this led to a discussion about what do we do about this, and we ended up getting hired to rewire nearly the whole boat. So between figuring out what all these wires were, labeling, removing them, and reinstalling them, 5 weeks later, we walked away having delivered this. Things are labeled.
That was all Yev, by the way. I was on this boat just for looking around, but that's all his work.
Valuable consulting, of course. This is a junction box that keeps the waters out with watertight glands on both ends. This happens to be at a mass base on a J105 we worked on earlier this year. We install a bunch of these, and these boxes come in different shapes and sizes, but they keep the water out. And what we like about this situation with, they're called, these are DIN rails, and this is a DIN whole ecosystem of components that clip onto these rails. But this is an easy way to disconnect wires when a rig comes out and be able to pull it together, put it back together without using screwdrivers or tools. I think we just need something long and pointy.
So basically, no tool job here. So when the boat goes to the yard and you've got the mast guy and the guy down below disconnecting stuff, and it's all kind of a hurry, and the guy down below has got a pair of clippers in his hand, and it's like, oh no, we don't want to see that. We want to give him the path of least resistance to take all the wiring out of the boat so it doesn't get damaged and it can come back in sort of in the same state. And these, we've gravitated towards these connectors, as it were. They're a terminal strip, as it were. And that little orange button, you depress the button and it releases the wire out of its jaws. It's a spring-loaded device. And it's super simple. Like, you just need something pokey to get in there to release it.
Yeah, great for troubleshooting. This is a project from a couple of years ago Eric worked on. It's an NMEA junction box. I think this is on PyWacket 68.
Yeah.
Under 68.
It might not look like that now, but that was probably 8 years ago.
Yeah, it's a dense system, but it's all there. It's all labeled. Keep complexity below your pain threshold. You want to talk about this one?
Sure. So the concept is, we can get really complicated. Especially if there's a big budget. But does that suit you? Does that suit your use case? Does that suit your, mentality, for lack of a better word? Is that what you want when you're in the middle of the ocean? I mean, you might want to have multiple means of communication. You might want to have multiple software packages running simultaneously. Maybe more exotic sensors, rig load sensors, rig position sensors, all kinds of things. So there's complexity that, we could use PyWacket as an example, that boats like that are going to have all this stuff. And we can put that onto a 30-footer. We have. But let's have the conversation about how you're going to use it and what you want from your system before we get overly complex. Because what we don't want is for the complexity to impact your enjoyment of sailing, right? That's what we're trying to do. We want to go sailing. We need some tools. We need some basic tools, right? We need AIS, VHF, good antenna system for both of those things. So there are things that are sort of prerequisites, but as we work our way out of there, we kind of do an interview process to talk about the type of boat, the type of sailing. What are you going to do after packed up? Are you going to continue on? Are you going to go to Mexico? Or is the boat going to deliver back to the bay and you're just going to do basic? So we kind of consider all those things, and we encourage all of you to think about, all the great things that you've heard about. Let's bring it to the table and see what makes actual sense.
Know your systems. Spinning off on the complexity, labels are absolutely essential. And I was mentioning, as you inspect and you learn what wires are, some of which are unlabeled, label them. So your investment of time in learning your boat and tracing wires, it does not go, give yourself a deliverable, essentially. Drawings are very helpful. The bigger the boat, the more essential the drawings become. I think the exact number is 31.5 feet. You need drawings if it's bigger than that. But jokes aside, drawings can be made for a boat of any size to ease troubleshooting and understanding of how everything works. Not just for yourself, but if you ever ask a marine technician to work on your boat, you'll save a lot of money and time on their part to just hand them a drawing and say, this is where things are, this is how things are hooked up. This is an example of a drawing that we worked on a boat together. Eric made the drawing at first, and I used it as a schematic to install the system. This was several years ago. This turned into an as-built drawing because it was revised by the end of the project with any adjustments that had to be made in the field. So device is added, device removed, anyway, a different layout. But you start with this, you end with this as an as-built, and you can reference it in the future if anybody else ever gets in the boat to work on it. Let's move on to the offshore power plant. So on the Pacific Cup website, that's how you get to it. There are actually 2 Excel spreadsheets that will help you kind of get organized with the power consumption on your boat. I just checked them. I don't think they've changed in 10 years, but they're still applicable, and they still need tailoring to your situation. This is what the spreadsheet looks like, and we'd suggest you or someone who gets off on spreadsheets digs into this and tailors it for your boat, and then sit down in the boat and turn all your loads on, figure out how much everything is drawing so that you can understand what your needs are, and project from here how you're going to cross the ocean with what you have. I think Eric worked on this boat. You can speak to it.
Yeah, so the main takeaway here is on Moss, they went to the effort of building sort of what they thought their loads were going to be, and then they measured what the actual consumption is. And I don't know if we have a slide for that later, but the point being that the manufacturer's spec sheets are often inaccurate. So actually measure with the equipment on board, which we'll go over, what the draw is from any particular equipment. So they did that here.
When you say inaccurate, do they tend to be high or low, or does it vary?
They tend to be high.
Not
Yeah, I
overestimate
think
their
that's,
power
yeah, if I were to guess, yeah. So they, yeah, so they did the calculations here. The main takeaway from this sheet, the reason we have this slide up here is that there's this big blank area. And that would be for the production from their second solar panel that didn't work. So they had no production, and they had to vastly change how they used the equipment on board. So just, cautionary tale.
So when you're going through this spreadsheet and filling out what your loads are, how do you find information? We just talked about spec sheets from laboratories under ideal conditions. Some consumption's overshot. Some of it might be under if your wiring is using undersized wire. You might actually be pulling a little more than you should be. But the only way to really find out is to test your exact conditions on your boat. With any one of these or multiples of these battery monitors, we feel these are essential on a boat to keep track of the power you're using. There are a bunch of different brands: Blue Seas, Victron, Xantrex. If you have a Balmar regulator, there are more current ones. We also have a round battery monitor that you could display how much alternator production you're getting and how much power your boat is using with what you have switched on. The common denominator for all these is they all listen to a shunt. It's a small device that gets wired on the negative side of your batteries, and it will inform your monitor the net load that's passing through. So the readouts you'll get are going to be the total amperage that you're either using or you're generating. So for example, if your alternator is running and you're getting 50 amps out of it, but you're running 10 amps of load, your net production is going to be plus 40 amps, and that's what's going to show up on a display. You could also, if you have a boat with a Victron system, or even if you don't, and you'd like to get into the Victron network, the Victron has a Servo GX device that talks to a lot of its components, and a touch display, like the top right, that gives you an animated flow chart of where power is coming from and where it's going. So it takes a little bit of learning to understand exactly what the numbers are telling you, but that's a one-stop shop or one-stop place to see diagrammatically what you're using. And also, if you have lithium batteries, or if you ever upgrade to some, I think someone talked about the battery management system. There are Bluetooth connections you can make to your lithium batteries that will give you, straight from the horse's mouth, the readouts of what the batteries are receiving, what they're discharging, and what the individual battery cell states are. And this is an example of, this is a screenshot from the Epic Batteries app. We install Epic batteries most of the time when we install lithiums. As you can see, the app will connect to them and tell you what their state of the charge is, and at your current conditions, so these must be charging. They're each getting about 25 to 29 amps, and this one here will top up in about 38 minutes. So it does rudimentary math for you.
So this gets back to our ethos about complexity. So this is another layer of complexity. So people sail to Hawaii all the time with a voltmeter and an ammeter. Right? The ammeter did have a shunt. That's how it did its job. But it wasn't one of these fancy pieces of equipment. It was 2 meters that were usually in the breaker panel of the boat. This is an improvement, and for me, this is required. It's not new edgy stuff. It is a little more work to put in, but the information that you get is much higher quality, and will let you manage your systems better.
Appropriate redundancy, contingency, spares. There's been talk of this today. Scott mentioned a bunch of spares to bring for rigging purposes and for electronics. It would be handy to have a spares kit on a boat. Highly recommended. A tool bag with offcuts of wires, with NMEA cables, with connectors for NMEA 2000 or Raymarine, or what kind of system you might have on your boat. White tape, basic tools to fix any kind of problems. Some specific stuff that I think is critical to have is Wago connectors. You can Amazon them and get like a box of Wagos. They're little clamp-on splice connectors, so you can splice wires together in a couple seconds without crimping, without special tools.
If you want to see what those look like, we do have an example of that out here.
Yeah, I carry some in my toolkit for just testing stuff.
That's perfect.
Multimeter for seeing if your production is low from your alternator. The first thing you want to check is how many, what voltage is it putting out, and a multimeter would be great for that. And if you want to see how many amps it's putting out, a clamp meter would be great for that. Both super handy tools. Are there others you might?
Yeah, clamp meter is an upgrade that's nice to have. They make a clamp meter that has you can put test leads into that would also be a multimeter, but it usually only goes to 1 digit past the decimal point, so I don't really like it. It just doesn't feel quite right to me. I want to have more precision than that. But you have to have a multimeter for sure. And yeah, so offcuts, tape. When it comes to tape, if you've got black electrical tape on your boat, it does not belong anywhere near the dock. Get rid of it. All right, I want to see white electrical tape, and if you need to have other colors, that's okay. But the black stuff just turns gooey, and it's a universal truth. I don't know why black electrical tape does this, but it turns into a ball of goo. So the white electrical tape is great because you can use it for rigging and electrical. We're already saving you work.
And you can Sharpie over it if you want to label something.
Yes.
Yeah, it's super.
And then what Yev talked about cutting tie wraps, and this is I'm the evangelist. So we want to use an absolute flush cutter, and I'm sorry I didn't bring any today, although I probably have them in the car to show you an example. But it's the back of the diagonal cutters is absolutely flush. It doesn't have any bevel to it, and when you snug right up to the tie wrap to cut it, you can't feel anything. You'll thank me later when you stick your hand into a cabinet that has a bunch of tie wraps on it and you don't tear yourself up.
I have a toolkit with me. There's one that travels with me to all the boats. I can demo basic hand tools that I'd recommend having with you offshore. Power production issues and failures. Well, I have a great example of this. I'm not going to name any names, but there's a boat I recently worked on that we did a huge, it snowballed. It started as can you hook up my radar? Because I'm going down to Baja for the Haha, and that turned into a battery upgrade and to lithium, and the boat was untested. We've done this plenty, but all boats no matter what need to get tested before setting off into the ocean. And on the way down the coast, I've been dealing with battery charging issues from an alternator that wasn't replaced, that wasn't tested. We had to fly a guy down. We had to overnight some packages. This just brings up testing and familiarity with systems should be done in the bay first, then offshore a bit. I mean, races like the Blue Water Bash or Qualifier are great for that, but test your systems.
Yeah, so,
Eric as examples.
I mean, the point being, use the systems that you're going to use to sail to Hawaii, use them in real world conditions. So, we don't want to put a new system in and run your alternator and see that you're getting 180 amps, okay, great, we're going to go get lunch now. No, I want you out there sailing around. I'd like you out for a day anyhow. Let's run your batteries through a cycle, run your engine so the alternator is working hard and gathers the amount of heat that it's going to have in your engine room when you're out doing this, for days on end, and really test it. We're going to look for are the belts up for the job? Did you upgrade the alternator, but the belts are still the same? Are they gathering the black dust, belt dust, because they're wearing unduly? Is the alternator derating because it's gotten too hot in your engine box? I don't know. There's other things I'm forgetting. Oh yeah, and then just sort of the basic, connections. That you're running your engine, everything's running hot, and the cable that's terminating onto the alternator, does that stay tight through all of this work? It's not uncommon at all that nut isn't tightened down sufficiently, and that cable starts to loosen up a little bit, and then it starts to arc, and it turns into a real hairball. So.
Yeah. Also, upgrading system or upgrading to lithium batteries, upgrading alternators. There's a cascade effect of wire upgrades and sizing that has to happen, and if any of that hasn't been done to the right size, you might experience voltage drop and losing power generation between the alternator and your batteries, and that will change as things heat up, as Eric mentioned. Alternators, as they heat up, they produce less power, so that plus voltage drop in your cables, how much are you really getting after running the thing for 20 minutes? It's something you test offshore.
Should we stop? Are there any questions? Because we've been yammering for quite a bit. Does anybody have anything to bring?
Yeah, new boats coming out of the box. Everybody did good work, we assume. What are your suggestions of how best to test this besides just going out there and doing it?
Well, so new boats. The question is about new boats and what the potential pitfalls are. So some new boats are put together really well, and some of them are, they're I don't know how to say it. Production boats are like a production house. The drywall might not be perfect, and the wiring might not all be tightened down and all that sort of stuff. So I think to answer your question, I would start by inspecting. So I would go through, and since we talked about doing that anyhow, that's going to be revealing. And we're going to assume that they follow the rules about wire sizes for any particular job, that their wire termination techniques are also sufficient. And you have to come down to the boat and look at it quickly and decide whether, there's the level of craftsmanship that we think is going to be suitable for offshore. But, those are the things that I think that's the starting point, is to inspect.
And you'll probably find a bunch of black electrical tape. Hasn't quite turned to goo yet, but it's there. Yes.
The question about battery management systems. It seems like they tend towards either Bluetooth connectivity or their own custom wired, like you showed the Victron display. Why aren't there more like NMEA interfaces so that you don't have an additional Bluetooth device or an additional
Yeah.
Like, does NMEA support the kind of information you want from the?
So the question is, why can't we get battery data ubiquitous around the NMEA 2000 network? And forgive me if NMEA 2000 is a new term. If it is, we'll be happy to explain that offline. NMEA didn't have the sentences to support everything that we want to see, so cell temperature, I don't know, what else? I mean, cell temperature is a big one.
Charging rates, like
Yeah.
current amperage for
Yeah.
usage, battery charge
Yeah,
levels.
so some of that now exists, but it's still not. Yeah, you're right. I mean, it'd be great just to be able to plug the data out of your battery into the rest of your system.
Are there systems that support non-standard NMEA sentences?
Like what do you?
Like, are there if the NMEA 2000 standard doesn't support all the data that we want? Are there does Victron have a device that publishes non-standard sentences that other NMEA devices do understand? Like, are there any solutions for it for getting all the battery management data that we want without adding additional devices and increasing our voting costs?
I'm not a Victron guy. I don't know if do they have an N2K interface of some sort?
Not that, I mean, I'm not sure. We'll have to look into that. I mean, I have a buddy up in Port Townsend. He started a company called Powerflow Marine. You guys might know Jack. He also has his company creates electric motors for yachts. And he has his own display that tells you what the RPMs are, what the battery states. He also makes his own batteries. And he can't get the stuff on NMEA 2000 because of the proprietary sentence situation. He has to, I don't know what the process is, but apparently he's applying for sentences that he can
Yeah, and
use.
it's a super slow process. Like MOB, I had lobbied directly to NMEA for an MOB sentence for years, and it finally came, and it didn't work right, and then a year later they fixed it, and so NMEA is a bit of a.
Of course, it is just a canvas, and you can put whatever you want on there. You can put whatever data you want.
Yeah.
So if you had some non-standard interface, you could.
Yeah, and I'll just address BMS for a minute. So battery management system is something that lithium batteries require to be able. It's basically the go-between between the outside world, the boat side, and the cells in the batteries. And the job of the BMS is to manage inflow and outflow in such a way that it treats the cells in a way that they want to be treated. I would say maybe even just 5 years ago, that was still a bit of, there was still a bit of edgy science with people figuring out how to what the right BMS was. You can get third-party BMSs to go with your batteries that had raw cells, and the people made their own batteries. We're past that tipping point. So the technology in lithium batteries now is pretty ubiquitous, right? There's not a lot. If you buy mainstream stuff, right? I mean, if you buy batteries off Amazon, I know there's probably 100 different brands on Amazon, and they're not all made in the same factory, and they are all of different quality. I wouldn't trust those BMSs necessarily, but mainstream manufacturers have really solved this problem. So we don't give it a second thought, and we haven't regretted it. It's lithium batteries have worked out. So.
And the failures I think that you mentioned out of the box, I personally have not seen that with the BMS in recent years.
Yeah, I think again 5 years ago, it was I was on the fence, but I'm over the fence now.
Yeah. Yes.
Okay, it's actually going the other way around. You have your Victron Bluetooth on your iPad. You have the repeater for your Garmin ENG chart plotter on your iPad. It's actually going basically, once you run around, it's just going on your iPad. You have access to all the information.
And I should add that if you do have a lithium ion battery, the Epic app, I've pulled up batteries by other manufacturers. They all show up on the app. So one app might rule them all. It's to be determined. Testing and sea trials. If we haven't brought this up yet, testing is a good idea before you leave the gate. We've talked about alternator systems, output ratings. Do they really match what you're getting? Again, voltage drop is a thing, and the only way you know is by checking it out. Solar charging, also testing that under real-world conditions. How much are you really getting? Solar panels you might have a 100-watt panel, but you're probably never going to see 100 watts out of that panel. The tilt to the sun, perpendicular, huge deal. Just a 10-degree tilt is a substantial drop in consumption or generation. Dust, atmospheric conditions, dirt, salt, water, all that stuff weighs in on how well those panels are performing.
Yeah, and bear in mind, like a lot of boats might have panels port and starboard. Well, one's going to be in the favored position, and the other one might be in complete shade. So, when you're doing your energy budget, think about real-world conditions, or better yet, go out sailing and see what really happens.
Sea trials, seat time, email, radios, AS, computer. Again, races like the Blue Water Bash or your 150-mile qualifiers, please get far offshore. Get 50 miles out when you're comfortably or uncomfortably out of cell phone range, and see if you can send an email. If your Iridium Go connects, how many satellites are you receiving? See if Starlink can get you to connect, how long it takes, how much power it draws, if you can send an email to home. And test your AIS. Find a buddy in the bay who is going to look for your transmits, your AIS position, and see how far you get before that's lost. And same with VHF testing. Funny story, actually interesting. I was wiring up a boat for a customer in this room. Won't say him by name, but beautiful boat, wonderful customer. And we ran a backup VHF, emergency VHF cable through the boat back to the transom. And I connected it to the AIS transponder splitter in the nav desk. And the other end was just hanging out. It was just loose, dropped in the transom, connected to nothing. And the rest of the system was already turned on, or it was ready to fire up. I turned it on, and I was seeing boats around us for about a mile out. And I think the rule is you see, and you can transmit a mile.
Yeah, so the rough, I don't, what are we going to talk, do we talk VHF now or later?
Sure, now.
Okay.
Yeah.
You have about 8 minutes left.
Okay. Pressure's on.
Yeah.
So for every foot of height off the water, you have a mile to the horizon. You can see a mile to the horizon. So if you're 6 feet off the water, the horizon's 6 miles away. Significance of that is VHF, AIS are all line of sight. So you're not going to see anything much further than the edge of the horizon. So your VHF system mounted at the top of the mast, we love it. There's a spec that inspectors will be quizzing you on that you have to, the amount of power that you have to deliver to that antenna, which means you have to have a certain type of coax cable. But we like that elevation because it gives you a long distance to the horizon. And this will be important with AIS, personal AIS transponders. So if somebody goes over the side, you're going to have a much more direct line of sight from a masthead antenna. What happens when the rig goes over the side, and Jim mentioned going and getting a 3dB VHF antenna, which is 1 meter long. It's not going to be any shorter. We sell race antennas that are shorter, and that's a whole different topic I won't get into. But this antenna doesn't require a ground. It's ground independent, and this is what you want. This is the best performing antenna for the job. The rig goes down, you have a length of cable, you plug it into your VHF down below, and now you can probably talk to a helicopter 100 miles away, because they've got a lot of elevation, and you can talk to other competitors more readily. So we highly recommend this. You put this in a plastic bag under a bunk and it disappears. Hopefully you forget about it and never need it. But
What is the brand of that?
I'm sorry.
What is the, excuse me, what is the brand?
The brand. This is this is made by AC. This is the only one that we use. That we import these from Europe someplace. They're super compact. It's the smallest and lightest weight version of this antenna that we've found. But having said that, as Jim said, you can get on Amazon or go to West Marine and spend under $50. I think it was like $130.
What brand is that, you said?
AC. But the point is that all of those 3 dB base-loaded antennas, it has a coil at the bottom, base-loaded antennas are the preferred tool for the job.
Yeah, emergency antenna. I'm going to finish my story about the AIS. So connected to nothing, AIS transponder, just a cable going 20 feet aft into a transom, just clipped. I was seeing targets a mile away. A VHF unit just hooked up to power with no antenna hooked up to it. You're going to be getting some weather channels, and you might hear some chatter on 16. You'll get something, but that could be misleading, and that goes back to the testing point. Is you only really know how good your system is if you test it. So go far from shore and get on the channel with someone that is listening, and do a proper radio check. 20 miles away, see what happens. And if they see your position on AIS. This is
Yeah, get it done early. Right. So if you're still in the thinking stages on anything that we talked about, you're late. So we want you to get going now, whether it's with us or anybody else. We want you to, because what we want is to get that stuff done soon so you can go out and beat it up. And let's figure out whether the system is up for the job.
Yeah, you need time to run the batteries down so that you can charge them back up. People are only available on weekends. It's hurting cats. Satellite communications have come a long way. I think some of you may have heard of Starlink, this little garage startup. There are 3, it's leading the pack with satellite communications. So there are 3 dishes to choose from, and we'll go through the general points, but we will happy to get in detail later.
Quick.
What's that?
Say quick.
Yeah. Flat high performance, big dish, most power hungry, heaviest, most power consumption. What you get out of that is a wider field of view and a more stable, faster internet connection. So if you're playing a World of Warcraft offshore, this is the dish to use. Standard Gen 3, this is the medium-sized dish in all regards, medium weight, size, power consumption, and a slightly smaller field of view. You see fewer satellites and hold a connection still remarkably well, but it's not as good as the jumbo. And the third is the mini, appropriately named. I wish they named them jumbo, medium, mini. Smallest size, weight, form factor, smallest power consumption. It's just like 3 amps at full tilt. Same field of view as the standard Gen 3, and this has built-in Wi-Fi, which is a great feature for small boats that don't have a Wi-Fi router or another Ethernet network system. These are all installs that we've worked on. Every installation of a Starlink on a boat is custom and different. The wires and the power supplies might overlap, but these are the 3 flavors to choose
Lots
from.
of different ways to mount these things, and we're happy to talk to you about. We don't sell Starlink. We install a bunch of them. So we're happy to talk to you about what mounting brackets and all that might be best for your project.
Yeah, and just one point to make, the mobile priority plan, which is the offshore connectivity plan, it applies to all 3. That used to not be the case, but the mobile priority now can be hooked up to any of these dishes. And just because you have a big boat doesn't mean you get the big dish, or small boats get the small dish. We just put a Starlink Mini on a spreader of a 100-foot rig, and that is plenty for the boat. Eric made it to Hawaii on one in February, on a boat in February with the
Yeah.
Mini.
I think we were the first ones to sail across the Pacific with the Mini. And the boat went on to Micronesia and sailed all the way back, and it was flawless. I mean, when I say flawless, it will drop from time to time. I mean, even if I've got Starlink at home and if I'm talking over Wi-Fi, which is how I have to do it there, it will drop occasionally. Same thing on the boat, maybe a little bit more on the boat, but you dial back and call back, as it were. And
Are they reliable? Those things are cheap when you take two of them with you, just in case one fails, or are they pretty durable?
but there's a whole wrinkle to that I won't get into right now, because unless you have two activated on a plan, changing antennas on your service plan, I couldn't do it on land. It gave me a headache. Yeah, so the reliability's been fine. It's physical damage is the thing that I'm most concerned about, because it is a thing that's attached to a boat that didn't plan on having that.
So do you leave that on all the time, or do you only switch it on when you need the
Up to you. It probably has more to do with power consumption issues than anything else.
Does the Iridium Go also does a pinging every hour or whatever you select there? So the Iridium Go also has this like ping function where it sends out a position signal every hour.
I don't know if the Go, I know the InReach, the Iridium InReach does that. I don't know if the Go
The
does.
Iridium Go does it.
It does, okay.
But for this race, you have to have the yellow brick anyway, so it doesn't.
Right, you're not relying on equipment that you're putting on the boat. It's not part of your system for the tracking.
Okay, and I'll speed this up. Iridium Go, so Starlink isn't required, but Iridium Go is plenty capable. It's gotten plenty of boats to Hawaii and back. It could be your primary means of communication, and it's a perfectly suitable backup.
We wouldn't recommend the exec or the Certus if anybody's thinking about those things. They're obsolete as far as we're concerned. So
You have to be able to make a phone call on this wake, so you can't do that with the Go. Oh, shoot.
With Starlink, if you are installing an Iridium primary antenna, you are required to have an external antenna, and for that we'd recommend, as far as we're concerned, the only option is LMR 400 coax, so you can get the maximum data strength, the maximum signal transmission between unit and antenna. Yes?
Sorry, you were saying you think they're obsolete.
Yeah, Iridium Go Exec and Iridium Certus, which are two different pieces of hardware.
Right.
We feel that they're obsolete with the advent of Starlink. Iridium Go is still perfectly viable, and you can go to Hawaii and only have the Iridium Go, and you're fine.
Right, you don't have the same capabilities that you have.
You don't have the
Sorry.
same capabilities, that's right.
But if you already own an exec, it's functions normally.
It's fine too, we just wouldn't spec it now. Yeah,
And you don't have InReach up there.
we don't have InReach. Yeah.
Reason for that?
No, I think maybe an oversight. So we didn't put InReach on the list. I like InReach. I find it a little more complicated than I can get my head wrapped around. Probably because I just haven't spent the time with it. But it's a phenomenal little tool. I think we were running like 6 or 7 days on one charge. InReach is essentially text messaging only. It also does tracking. So anyhow, InReach is a great device.
Downloading grids or weather files, not something you can do with an InReach.
That's right.
I think these are more for
Should be a secondary.
data. Inmarsat, Eric has plenty of experience with this, but it's obsolete. SSB and modem.
I'll just touch on this. If you've got it, it's kind of a nice thing to have because it's a one-to-many communications with single sideband. If you get in trouble, you could probably get a ham radio operator, located somewhere in the world that's next to a telephone that can call somebody for you. We haven't installed sideband in years. but if it's an existing system, maybe you think about keeping it. If you're going to go to Baja and talk to other people that are cruising down there, then it might be a useful tool.
VHF AIS, I hear there is a requirement.
Does the Coast Guard still monitor the single side band?
They don't.
Okay.
Yeah, not that. That's the last I heard. Coast Guard is no longer monitoring 2182 on single sideband, which was the emergency channel.
For VHF requirements, as far as it being on that, you can confirm. Don't go off this. Confirm with Bob, Jim, Michael, Tony. DSC distress button. This is an important one. Not everyone knows exactly what this red button is on a VHF unit. In an emergency, push the button, and you get a broadcast to anybody within range with DSC-enabled VHF, your boat name, your MMSI number, your position, and that you're in distress. And the Coast Guard presumably will receive that also. And it's so having a DSC ready or enabled DSC
So
VHF is
this rule came into play a long time ago. So there are very few VHFs out there. Be on an older boat that doesn't have the red button. If you have a VHF without the red button on it, you got to replace your radio because it's a basic piece of safety equipment.
And it's a two-way street, so if you don't have a DSC-enabled radio, you can't receive transmissions from other DSC broadcasts. So if you have a fellow competitor in distress and they're pushing the red button, you're not going to see it if you're not DSC-enabled.
It is required for backup.
Okay, perfect. Emergency antenna required. This is an example of one that we love. And coax loss calculator, that's a resource on the Pacifica website to figure out your cable runs, what kind of cable you're using, and to calculate if you're within the loss acceptable range.
Is anyone not familiar with the cable loss calculator for VHF? Okay, so we can talk offline, but that's something that needs to you need to be aware of because it can an inspector will tell you got to do some work. Yeah.
Okay. That's a lot in an hour, but thank you.
Thank you, guys. Do we want to do anything with the presentation here? Galen next is going to tell us a little bit about some of the